Yeah, hi, good evening, everyone. So, today we have the first open session for week 10. Am I audible? Yeah, Chetan, thanks.
Yeah, Satya.
Okay. Yeah, so before starting the session, do you have any query, specific query? Have you watched all the video lecture from week 10?
Yeah, sir. I saw that and I have some doubts, sir. You can continue like that, and
Mm-hmm.
in meanwhile, I will ask.
Okay, fine, thanks. Okay, let me share my screen. Okay, fine. Yeah, so in week 10, we are learning the string matching algorithms. Okay, so you all know about the string matching things, how we can compare, how we can find one string into the another strings. So this is very common requirement when we work with any documents things. So you know that these things, so we can find any word in our documents, we can replace any word in our documents. So this type of operation is the daily type of needs nowadays. So how we can perform these operation efficiently? So in this week we are learning different types of algorithm for string matching. Okay, so we will start from the first things, how we can find, how we can perform string matching using the naive approach. Okay, so for example, so this is the first problem, string matching. You all know about this. So how we can perform string matching? So for example, if we have one text. Okay, so text contains a strings, and we have also a pattern p, and we want to find our pattern in our text. So during finding, we want to return the index of matching place. If we are finding out the pattern in our text, so what is the index when our pattern is matched in the text? Okay, so this is the problem, and this is very common things. So how we can perform this operation using the naive approach? So this is the force approach. It is given. So simply, if we want to perform this operation, so first things, we simply can perform using a two nested loop. Okay, so two nested loop, here we are performing one for loop, and second loop we are performing using a while loop. Okay, so I'm just taking one example, and then I'll explain that how we are performing this brute force approach. So for example, if we have a one pattern, so I'm taking this pattern, I think this pattern is very long. Okay, so I'm just noting now. So a b a b. Okay, so I'm just taking a small part. Okay, so because this is very long. So, and this, for example, this is a text, and the pattern is like this: a b a b. Okay, so this is text and this is pattern, and we want to find out this pattern in our text. What is the position of matching? So how we can perform this? Simply we can start matching from the first character. Okay, so we can start the position of first index of the text, and we can start matching from the first index of pattern. Okay, so simply if these first character are matched in both text and patterns, so we can increment our. So for example, I am taking I for this, so I for this, and j for this. Okay, and so simply if first character is matched, we will increment our both pointer by one position. Okay, so for example, this is match, then we will move to the next character. So we will increment our j here. Now we will check for this position. If this is also matched, then we will move to the next position. Okay, so this is also matched. Same things. Then we will move to the next character. And at any place, if our pattern is complete and all characters are matched, then we can say that the first index. Okay, so this is the index 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here we can see that our first position we found that where our pattern is matched is 0. Okay, so from 0 index our pattern is matched completely. Okay, so we can note down this index in our output list. And after matching, so for example all characters are matched, then we will shift our pattern one position to the right. So okay, so A, B, A, B. Okay, now we have shifted one position to the right, then we will start the same procedure again. Okay, so A to B, we will start from the A to A and B. If it is not matched, then we will shift again one position to the right. For example, here this B and A is not matched. Okay, so we will shift one position to the right. So in that way we can perform this searching. So like this A, B, A, B. Now the matching character is this A and this A. Okay, now this is matched, and second character is B, B. This is matched. This A, A. This is also matched, and this B and this B is also matched. Okay, so all are matched. We can note down the index of this two. So two. Similarly, then we will move one character to the right position. So A, B, A, B. Then we will start the same process again. So in that way, we can perform the naive approach that we are performing in the code. So if you see the code now, so you can see that this part here we are getting this list for the output, and we are performing we are just using one for loop from for I in range len of t minus len of p plus 1. Why we are taking this? Because we want to move only this position. So for example, length of this pattern is 4. Okay, so we will shift only this position. Okay, so where the 4 characters are remaining in our text. Okay, so here we will shift only till now, so we can just compare a b this position. Okay, after next shifting, definitely our pattern will not match because here 3 characters are remaining and our pattern contains 4 characters. Okay, so because of that we are just taking first loop from 0 to 5. Okay, so that value we are calculating using this loop len of t minus len of p plus 1. Okay, so I loop we will use in that way. We are just taking the one flag variable match, and we are just assigning by true and j equal to 0. While now the second condition, this is for pattern. If any time our pattern is matched, we will always reset our j to the 0. Okay, so here you can see if our pattern is matched any position, so we will always start from the first character in pattern again. Okay, so because we have to set our to 0 in our code. So inside this for loop we are so for every value of I we are just assigning this match equal to true and j equal to 0. After that we are just starting comparison. Okay, so this j we are starting from the while j is less than len p and matched. So both conditions are true, we are just performing the comparison. So here we are just starting comparison ti plus j and t. If value are not matched, okay, so here one condition is given. If ti plus j does not equal to pj, that means we are just simply comparing our characters. If characters are not matched anytime, simply we will assign match equal to false. So in that case, and we will also increase our j by j plus 1 in the next iteration. At any time if our characters are not matched, so at next iteration our while loop will break, because match this condition will not be satisfied in the next iteration. So this is the way when our characters are not matched, we are just breaking this loop, and we are moving to the next things, next shifting. After shifting we are just we are starting comparison again. Okay, at so this is one more condition. So for example, after completing this loop, while loop, okay, so if for example if our all characters are matched, so simply in last we will check that if matched equal to true, that means our all characters are matched. In that case this match will remain the true, otherwise it will become false. So if matched equal to true, so we will simply append the position in our output list. Okay, so this is the simple naive approach we are performing in the
Yes. So
pattern matching.
one question in this,
Yes.
in the while loop,
Yeah.
when the j exceeds or is equal to the pattern length, then I will change by one, right? Then I'll get out of the loop and I will increment by one more.
Uh, here where we are increasing I.
So if we are saying this while loop is there,
Hmm.
now in that while loop, suppose we come to a situation where j is equal to the pattern length,
Okay.
then we'll go out of the while loop, and then again it will go into the for loop for I in range. Is that
So
how it
yeah,
works?
so that condition will come when j is greater than the length of p.
P,
That
right?
condition will come when our pattern is completely matched.
Okay.
Okay, so that
Uh,
condition will all
but I
come
may have
because
another pattern, so I can then it'll come out and go to the for loop, and where I will change by one more. Will that happen?
no, I'm not getting.
So
Mhm.
if it comes out of the while loop, we'll go to the for loop,
Yeah,
right?
for loop. So here we are
Uh,
increasing the
I by
position
one.
of I. Yeah, I by
Right,
one.
right. That's what I was asking. Right,
Hmm.
right, right.
Okay, so this loop will complete in two condition. There is one condition when characters are not matched. In that case, it will break before the length of p. And the another condition is that if all pattern character are matched, and after that this condition will become false. So we will move to this condition, and this condition will also become true, and we will append the result if all characters are matched.
Right.
Okay. So this is the naive approach. So in that case, what will be the complexity of this code? So in worst case, so for example, what will be the worst case for this? So I'm simply taking one condition for pattern and text. So for example, T, and I'm just taking one strings. Okay, so A, okay, and I'm taking another pattern P equal to this is A, 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 B. Okay, so for example, if we are searching this pattern into this text, so in that case you can see we will start from starting always. So here if first value is matched, second value is matched, third value is matched, and last value we are comparing and it is not matched. So for example, we are performing all comparison, but in the last character we are getting the unmatched character. So in that case, we will shift our pattern one position to the right, but our pattern is not matched. Okay, so we will not find any matching pattern. So we will shift only this in this way, A, B. Again, we will start the same things. Our so n. So for example, our length of the pattern is n. So every time our n minus one character will matched, but the last character will become not so not matched. So in that case, we have to shift it to the right position. So same things, not matched, not matched, not matched. Sorry, matched, 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 and not matched. So we will again shift our pattern one more position. So A, B. Same things. Okay. So this is the worst case for our string matching. So in that case, you can see that we are performing for every value of I. We are performing our this complete loop. Okay, so for example, if the length of this text is, for example, m, and the pattern length is n, so for every value of I, we are performing n time of comparison. So in that case, what will be the complexity? M into n. Okay, so this will be the complexity in our worst case if we are performing our string matching algorithm in brute force approach. So this type of situation we can avoid. So for example, the starting characters are most of the starting characters are matched, but the last remaining characters are not matched. So some last characters are not matched. So we have to perform the all m into n steps to pattern matching. So we can avoid this. So we can change little bit this implementation. So we can start comparison from the last. Okay, so this is the another comparison, but we will not get any benefits for this, but we are just simply changing this implementation. So in the second approach nested scan from right to left. Okay, so we are performing the same approach, but this time we are just comparing from the last position. So there is a chance so we can improve our complexity in some case. So here what we are doing simply, we have our pattern, so like this a b a b a b b a b. Okay, the same pattern given ever, and this is next a b a b. Okay, so this is text and this is pattern. So this time we will compare from the last character. Okay, so we will just find out the what is the position of the so what is the length of this p, and based on this length we can decide what will be the last character will be in the text to compare to the pattern. Okay, so we will simply match this b. If this b is matched, we will just reduce both counter pointer to -1. So this a is matched, then we'll move to the left, then b is matched, then we will move to the left, then a is matched, same things. Okay, so here we are just start comparison from the last position. Same things, if all are matched, then we will move to, we will shift our pattern one position to the right. Okay, so a b a b, yes, same things we will
So this shifting position to the right, that is being done by the J plus 1, is it?
yes, shifting position to the right. Okay, so in code we can see that what we are. Okay, so
No, even in the previous one, I was getting a little confused. That was it
yeah,
being
so
done?
here you can see that now here we are using this I plus j.
Okay.
This is performing the shifting because in the first iteration this I is 0. Okay,
Yeah.
so in the next iteration when we are just iterating the another time, this I will become 1. So here the position of this pattern j will always start from the first character. Okay, so this will start from the 0
Okay.
in the previous code. Okay, so this is okay, so this one is the previous t I plus j. Okay, so here you can see that this j will always start from the
Yeah.
0, but this ti plus j will start after shifting one position.
Okay. Okay. So it is basically based on the I that we take. So it will shift that much.
Yes, yes.
Okay. Okay, sir. Yeah.
Hmm.
Got it.
So this first loop is just actually taking care of this shifting. Okay, and okay, so same things we are performing in this loop, but here this time we are just starting comparison from the last position. So if you can see the code, so here what we are doing, we are just using this I loop in range, same things. Okay, so we are just len of t minus len of p plus 1 and matched equal to true. Here this time we are taking j equal to len of p minus 1. Okay, so j we are taking the last index of our pattern, and in the condition we are just using this we have changed this condition if j is greater than equal to 0 this time. Okay, and same things we are performing if j plus so I plus j. So here we are deciding the text position for comparison. This is the pj. So this first things, so this we will get the last position to compare in our of text in our pattern. Okay, so after little change, so we can perform these things. This is not very difficult, I think. So, but the approach is approach same, but this time we are just starting comparison from the last position. So we can avoid some extra things in most of the case. So where we found the similarity in the starting, but not similarity in the last. So this is about the naive approach.
So
Okay.
which one would we give better efficiency, like on what cases?
So, for example, if in the so what will be the worst case for this? Okay, second approach. So second case approach, what will be the worst case? So I'm just representing like this a. Okay, so for example, this is the T, and our pattern is like this b a. Okay, so every time we will start comparison from the last characters. So this we will get the matching, but in the last character we will not get. Okay, so then we will shift our pattern once position to the right. So a. Okay, so here this is matched, this is matched, this is matched, but this is not matched. So in that way we will get the same complexity m into n. Okay, so you can use any. So most of both are approx similar. Okay, so but we are just using this second approach in our remaining algorithms. So for example, next algorithm, Boyer-Murray. So to avoid this situation when the starting characters are matched but last characters are not matched. Okay, so no need to compare these two algorithms, both are similar.
Okay, sir. Yeah, thanks.
Okay, now how we can improve this naive approach? So the first algorithm is Boyer-Murray algorithms. Okay, so what is the approach in Boyer-Murray algorithm? So for example, so in our text, okay, so for example, if we have a text, so okay, so A B C C, okay, and our pattern is like this: A B A. Okay, so for example, in this case, so T, if this is a T, this is a P pattern. So here you can see that we are just searching ABA in our as a pattern in our text. So here you can see that there is one character C. Okay, this character is not exist in our P. So for example, if we are using the second approach, okay, so the comparison from the last position. So in that case, you can see that if we will just compare the first character. So C and A, this is not matched. Okay, so we will, according to the naive approach, we will just shift our pattern by one position. So A, B, A. Okay, same things. Now we will start from here. This is matched, but C, this is not matched. Okay, so then we will shift again one position to the right, then A, B, A in that way. Okay, so we will perform in that way by the naive approach. But what happen if this C is not exist in our pattern? So why we are shifting one position? Because after so what is the length of this pattern? 3. Okay, and the first character is not matched. Okay, so C and A is not matched. Also, you can see that this C is not exist in this pattern. So after shifting one position, you will not get the pattern matching pattern. Okay, so because you will compare by the this position. So if C is not exist in this pattern, so definitely you can avoid all three position for the searching. Okay, so so for example, this C is not exist, so we can shift our pattern by three position directly. So for example, in the first case, if this is not matched, so we can check that C is exist in our pattern or not. Okay, so if this is not exist, we can shift our pattern according to this situation. If C is not exist, so we will shift all three positions. So we can start comparison from this position. So A, B, C, sorry, A, B, A. So after this step, we can move to this second step. Why we are performing these steps? Okay, so how we can do this task? How we can just check these things if our any character is not matched from the text in our pattern. So we can also check these things, that character is exist in our pattern or not. If exists, so what is the last position of our of that character? If not exists, then we can shift completely our pattern after that character. Okay, so this concept is using in the Boyer-Murray algorithms. So okay, come to the Boyer-Murray. So here you can see that some points are given for the algorithm: text T, pattern P of length N and M. For each starting position I in T, compare. So this is the comparison part. Okay, so so this is the main point. While matching, we find a letter in T that does not appear in P. Okay, so for example, here one example is given: this B A N A N A M M A N I A. Okay, and P is given. So this is T, this is P, B U L K. Okay, so here you can see that if we are just comparing from this A, you can see that A is not exist in complete pattern. So there is no need to shift one position. You can shift after this character directly. Okay, so you can shift after this character, so like in that way, so you can shift in this position, B U L K. Okay, so now the pattern the last character is this. Again, you can see that this A is not exist. Okay, so you can directly skip all remaining position in the patterns, and then you can start the next thing. So here now the few characters are remaining, 3 characters, so we can return the answer. There's no matched. Okay, so this is the main concept of Boyer algorithm. So how we can store this information? So what character of the pattern, what is the last position of the pattern character in our pattern? Okay, so this is the main things. So this is the first condition. If not exists, shift the next scan to the, okay. So after mismatched letter, what? This is the second condition. What if the mismatched letter does appear in P? Okay, characters which are not matched in the pattern. So what is the so what we will, so, okay, so if it is exist in our pattern, then how we will shift our pattern? So this is the second condition. This first condition is that if character T is not exist in our P. Second condition is that if characters which are not matched, if exist in our P. So we will handle these two conditions. So before handle this, so how we can, so the first step is this pre-process. Okay, so we will maintain one last dictionary. What is this last dictionary? Here in this last dictionary, we will store the last index of each character in our pattern. So for example, okay, so here ABC is not, there's no, okay, I'll explain that here. So for example, if we have a pattern P, and this is like this A B A B C. Okay, so for example, if we have a pattern P, so we can maintain a dictionary, we generally call this last. Okay, that contain information. So for example, how many characters are there in our pattern? So there are 3 characters A B C. Okay, so that means we can create a so A, B, and C. So here you can see that the index 0, 1, 2, 3, 4. So what is the last index of A in our pattern? This is, so first is here and second is here. There is no A after that. So last index is 2. Okay, and what is the last index of B in our pattern? 3. And what is the last index of C? This is 4. Okay, so we can maintain a dictionary of each character in pattern. So that dictionary contains this information. What is the last index of that character in pattern? Okay, so we can use this information to shifting. Okay, so how we can use this? So for example, now we have we have text. Okay, so A B, so C B A B B B, like this. Okay, and what we have one pattern, so same pattern, this A B, so A B A B C. So here you can see that if we will same, we will start matching from the last character left to right, sorry, right to left. So if this is not matched, okay, so last character is not matched, A to C. So what will be the position for the shifting? We can decide based on the last dictionary. So we will simply check that what is the position of A in our pattern. So there is a
But
chance.
sir, in this first we'll have to know whether A exists in the pattern. So that
Yes.
we'll have to first find whether A is existing in the pattern.
Yeah. So in that case, we will first check these things, if this A is exist or not.
Okay.
If
So
it
we'll
is
check from the
exist,
last. So
yeah,
if
in
it
the
does,
dictionary. Yeah,
okay.
we will check that A exists in
Exist in
last.
dictionary. Okay. Okay.
Okay, if it is not exist, we will completely shift our pattern
By
uh,
right to
to
by
the after this
I
character.
plus one. Right. Right.
Yes.
Right. Right. Right.
Okay.
Okay.
Otherwise, if it is exist, then we will find out the position of the last index. So for in this case, so what is the last index position is 2. So that means we will shift our pattern in that way. So this last index will come below this A. Okay, so
Okay.
here we are getting this 2, so we will just use some code for this. So the normal, so simple logic is that we will shift in that way, so that this A will come, so in the pattern the similar character will come below. Okay, for the matching. So okay, so after, for example, so in that case we will shift our pattern like this way. So A, B, C, and then the first is A, B. Okay, so that means we will shift 2 position directly.
So basically we pick up the last element that is there in the text based on the pattern,
Hmm.
based on the length of the pattern, right, sir?
Yes, yes.
Okay.
Okay, so
So
here
how are
this,
you shifting this? How, what
so
is
that part we are doing in the course. So some, okay, so logic we will use for that. So here I will explain the code things again. Okay, after this explanation.
okay, sir.
Okay, so in the second case, so after shift, so here you can see that, so in the naive approach we will always shift the 1 position, but here we are shifting 2 position directly, because the last matching character position is after 2 position with respect to the not matched character in pattern. So again we will start the same things. So here you can see that this A is not matched with this C. Okay, so same things, we will check the if this character is exist in our pattern or not. If it is not exist, we will skip completely, otherwise we will just check the position. So 2, same things, we will once again shift 2 position again, A, B, A. So what is the B, C? Okay, so is, I think there is no matching character. Yeah, so I'm just taking one example, A, B, A, BC, matching strings. Okay, so in this case once again we will just check the last character, so B and C. Okay, this time this is not matched. Okay, so at any time it is not matched, we will simply check what is the position of 3. Okay, so that means in that case we will shift only 1 position, because after 1 position shifting, it will be, this B will come below this matching B. So in that case, A, B, C. Okay, same things again. So B and C is not matched. We will shift 1 position again. A, B, C. Okay, so same in that case. This, so this AC is not matched. Then we will shift 2 position directly. So A, B, C. Now this A is not matched with C. Okay, so we will shift to B, A, B, C. In that case you can see that all characters are matched after that. Okay, so here you can see that here we are skipping skip some, we are improving this shifting, and we are skipping some shifting part. Okay, if our
Sir,
character is
we are
not,
shifting first, actually, first and third element of pattern is A. So that we are shifting two things actually, two positions. If it is like A, B, A, then how it will be?
so what is the last position? So what example you are taking?
Okay, it depends upon the last position. How much
Yeah,
position is there? We require to shift like that.
yes. So here
Okay,
we are storing the last index, based on that we will perform the shifting.
okay, right.
Okay.
So basically here, like the first two iterations, we got A. In the third iteration, we got B. So
Hmm.
since the dictionary has B as 3, it would move 3 places, right, sir? The next time.
So what
So the
example you are
arrows
taking?
that you've shown in the same example, the text.
Mm-hmm. Okay.
Here, the first time you saw that A and C don't match in the text and the pattern.
Yes. Okay, fine.
And then you move 2 places because the dictionary says that it has to move 2 places. So you come to the A. Again, A and C don't match. So now you
Hmm.
again move 2 places and you come to B. So now B
Yes.
and C don't match. So you see B, look up B, and then B has 3. So you move 3 places, right, sir?
No, I am not shifting 3 places here.
Why, sir? I mean, why still we move only 2 places?
No, we are not shifting based on that.
Yes.
this value
So
directly.
is
We
it
Yeah.
will find out the what will be the
It
what
has to
character
be
we can
aligned,
shift.
I think. It has, you have to
Yes.
shift by to align it.
Depending upon the first element of the pattern, we are catching the first element of pattern, and
okay?
we are seeing only the first element. It is two last position. So every time we are moving two position.
So we will calculate these things, how many character we can shift. So this is the last matching three. Okay, three. So what is the length of this pattern is 5. Okay. So based on that, we will calculate if the our character is matched at the three positions. Okay, so that means total last index is 0, 1, 2, 3, 4. This is the length. Okay, our patterns. So the last index of B is 3. That means our element is exist in this position 3. So in that case, we can shift only one. So we can use this concept. We can simply reduce this thing. So length of T, length of P minus what is the value of this last, okay, plus 1.
Okay, okay. So now I got it. So you are actually doing this calculation and then moving it.
Yes, based on that we
Okay,
will
okay, sir.
calculate it. Okay,
Yeah.
so we are not just using
Could
this
you explain
value
in
for
max
shifting.
that fourth line item? Fourth line, I didn't understand. This length of
uh,
P minus.
Even I didn't understand. How is it
Yeah.
shifted by one by this formula, sir?
okay, so here you are getting this 3. Okay, len of P is 5. So 5 minus 3 and plus 1. No, not plus 1, sorry. Okay, so we will use
Actually,
minus 1.
why suddenly BS came, sir? Actually, we are going through A, through and through. For third line, up till third line, we are in three. A only.
No, so third line for this one, you are talking about this line.
Till third line, A, we are taking reference of A and we are shifting that particular pattern.
Yes,
And on
yes.
fourth line,
But here we are not. So you are simply looking at this. Here we are getting two value and we are shifting two position. But we are not deciding this shifting based on this value directly. Okay. So we will calculate the shifting value using this value, but this is not the same exact shifting number. Okay.
That
So
is clear. That is,
yes,
it does not depend upon the dictionary value, the
yeah, dictionary
shifting.
value. Yeah. So we will
It depends
calculate the
upon how
shifting.
you align it with the text, with T.
Hmm.
So
So
how
for
many you have to move to
so
align that? So how,
yeah,
what is
so
the
we
formula
can.
for that?
Yeah, so formulas we can use in that way. So, for example, len of p minus what is the last value of our characters and minus 1. Okay, so because the last index is here 4.
Okay.
Okay, okay, so we can decide this formula. Otherwise, we will also look the code how we are
So what is the
using this.
logic of this?
Which
how to
means
see
we are
whether it is
using the dictionary, right, sir?
Yeah, we are using the dictionary.
Dictionary, yeah.
Yeah, here we are using
how to
dictionary.
choose whether it is A or B or C? How we require to choose that?
So this part.
Line of B when it is
So
C.
for pattern, you can simply create this last
Yes, sir.
dictionary, na?
Previously we started with
So
A.
for hmm.
We are shifting with A only. Once we didn't found any abnormality, we just shifted with A 2 units. We have shifted, and
No,
suddenly
no. So same things I am repeating now. We are not deciding the shifting position using this direct value too.
okay.
We are just using this value and we will calculate the shifting position using this two value. So the formula will be different.
So what is the logic of this formula? Length of P minus last minus 1. That I didn't
So
understand.
hmm. So how we are just shifting? Okay, so I'm just explaining in this example. Okay, so here we are getting this two. Okay, so two value. That means our index, the last index of A is at position 2. Okay, and what is the unmatched character is uh, at the so at the fourth index. We will also use this. Otherwise, we will. So, for example, in some case, so three characters are matched. Okay, so A, B, so like this, C, C, and B, C. Okay, so for example, this is our text. Uh, B in that way, and the next thing is A, B, A, B, C. Okay, so the first character is matched, second character is matched, then now third character is not matched. Okay, so but we will look the what is the last position of this C is in our dictionary is 4. Okay, so in that case we have to decide the things what we will do, because this character is coming at this position that we have already compared. So we have to decide the formula. So we, okay, so I'm just showing the code what we are doing this thing. So now the concept is clear.
Concept is clear, sir.
Okay, okay, now we will decide the how we are calculating this value. So in the first in the loop, so this is the first process to create a last dictionary. So this is simple. We are just traversing the all character in our p pattern, and we are increment our, so here the last p of I equal to I. So simply we are just storing the last index. So at any time, for example, a b c a b, so in that case we are iterating, so we are just creating a dictionary. So if this a, so we are just using this dictionary. So last of a is, so what is the index of this is 0. In the next iteration, for example, at any time when we are reaching this position, so this index is 3, 0 1 2 3, yeah. So we will replace this value, so last a will become 3. Okay, so this is the simple, we are just storing the last
So
index.
basically that
Okay,
0 will be overwritten by 3, right, sir?
yes, overwritten by the 3, because this is already exist in our dictionary, so this
Okay,
will
sir.
overwritten by 3. If it is character is not exist, it will create. Okay, so here in the second iteration, this b is not exist at that time, the new key and value will create in the dictionary. If it already exists, then we will update. So this is the simple, if we are just saying that what is the length of our patterns, if it is m, so simply big O of m time we can calculate this. Okay, so this is the linear operation, we are just traversing complete pattern, and then we can calculate this information. So after that we are just performing these things. So here you can see that same things, we are just taking this condition while I is less than len of t minus len of p. So here okay, so len of t minus len of p.
Should be plus 1, no?
Yeah,
Len of
that.
t minus len
So
of
this
p
time
plus.
we are taking this less than equal to condition.
Okay, okay. Right, sir.
Okay, so same things matched, we are taking to j, we are just assigning by the last character. Okay, similar to the last code. Now here we are just checking this condition while j is greater than equal to 0 and matched. Okay, so this is the this loop we are taking for the text, and this loop we are taking for the pattern. Okay, if ti plus j does not equal to pj, same things if last character are not matched. So we are just assigning this match equal to false and reducing j equal to j minus 1. That means in pattern we are reducing this j equal to j minus 1. If it is matched, same things we will also perform this j equal to j minus 1. Okay, so if all characters are matched from the last, so like this a b c a, so our pattern is a b c, so we will start the comparison from last position, and in that case this loop will complete. After that we will get this matched equal to true, and then we will store our starting index in our result list, and we will increment our I loop by 1. So here you can see that the same things we are doing. Okay, but what happen if the last character or any character is not matched? Okay, so after performing this while loop, if at any time if this match equal to match will become false, we will stop this loop. Okay, so because in the next iteration this match will become false and it will be break. So we will check the second condition, and here this condition will not be true because it will become, it have already become false. So now we will come to this else part. Here we are just getting the value from the last tree, what position we have to save, because during the not, so if characters are not matched, okay, at any time if character are not matched, we are reducing this j equal to j minus 1. Okay, because of that we are again increasing this here. Okay, because this j equal to j minus 1 we are
If j
using for
is
the
equal
both.
to j minus 1, why we have done, I didn't understand, sir. And again, why
No,
we
so okay, so actually we are starting comparison. So here we are taking I equal to in the first loop 0. Okay, so and we are taking the j equal to, we are starting from the length. What is the length of our pattern is here 3. 3 minus 1 is 2. So what is the last index of j is 2. Okay, according to this. And if you are comparing, so if characters are matched, then what we will do, you will reduce this j no, j2 minus 1 to check the previous character.
okay, right, sir. Right. Thank you.
Okay, so because of that we are reducing the j equal to j minus 1.
Even if it is not matched, it'll reduce by,
Yeah, if
yeah,
it is not
because
matched,
it has to
we are
match.
also
Yeah,
if it is
right.
not matched, still we are also reducing because this is a common
So
on both
that's why
sides.
we are adding one to get to
Yeah,
that same
here we are,
position.
if it is not matched, we are adding this again.
Okay,
Sir,
okay.
that is why we are. I mean, if it is not matched, even then we are reducing. Why is that so, sir?
So you can use the else part for this. Okay, so this
Okay.
is not and you can remove from here.
Okay. It is
Okay,
just to
so
have a
that
similarity with the previous code,
yes,
is it?
yes.
Okay.
Okay,
Okay.
so that small things can be different. Okay, so here if you are just using this j for common both condition, so we are just increasing by 1 when the characters are not matched. Otherwise you can take the if condition at if characters are matched, then you can reduce, otherwise not reduce. Okay, in that case you can remove this part.
Okay, sir. Yeah.
Okay, so if the anytime if characters are not matched, we will come here, and in that case we will check the last value. Okay, so if ti plus j in last, first we are checking the characters exist in our last or not. Okay, so this first condition is for that. So
What is
so
Ti plus J here? So in this example, it will be
yeah, because here
2,
we are starting I from the starting. Okay, so we this I is 0.
right?
Okay, and character are not matched. For example, this case is the last position. So what will be the index? 2.
2,
So
2, yeah,
0 plus 2 is 2,
2,
and we are checking the last value for this, which are not matched.
right, right.
Okay, because of that, we are just taking this ti plus j
Okay,
in last. If it is not exist, so we can completely ignore the completely skip after this character. So because for this we are taking this condition, so we are deciding the I position. Here you can see that we are calculating the I position for next comparison. Okay, so here we are taking I equal to I plus, so last value is I equal to 0, and plus we are taking max of j minus, so what is the j index? Okay, so in that so we are just picking the last index which are
J
not
is
matched
2,
in a pattern. J is 2 minus what is the last position of that character c.
okay,
Okay, so now we can compare these things here. So in that case, what is the dictionary? A. Okay, so A is here. Now the J value is 4 for here. Okay, J equal to 4 because 5 characters are there. In the first iteration, I equal to 0. Now last character are not matched. In that case, J equal to 4. So we will just simply taking J minus. Okay, J minus. What is the last value of A is 2. Okay, 2, and we are simply we are simply okay, so we are not doing anything. Okay, so we are not reducing because we are taking the last index, and comma 1. Okay, comma 1, what is the max value for that comparison? So which is max we will take as to add in this I, and based on that we will shift our pattern. So here you can see that I equal to j minus j is 4, 4 minus 2, and comma 1. So what is the max? So this is 2. And what is the previous value of I is 0. So 0 plus 2 will become 2. That means we are shifting I equal to I plus 2. So what last value is 0, and then now the next value is 2. So in that case you can see that we are shifting 2 position.
So, but I didn't understand the logic. The formula is clear. It is shifting that A is shifting by 2, like you said. But what is the logic of this? It's not clear.
uh
The formula
Logic.
logic.
Okay, formula logic.
Yeah, why max of this?
Yeah, max part, actually there is one situation. Okay, so what will be the situation when we will select this one? Okay, so okay, we can just find the case for that.
Could you write that formula here, sir? It is easy for.
Yes, yes.
So I equal to I plus max j minus last, and we are taking I plus j. Okay, and 1. So this is the formula. Okay, for selecting the I when the characters are not matched. This formula we are using when a character is not exist in our pattern. Okay, so why we are taking this one? For example, if we have a text T, okay, and like this, so C B A, okay, A B anything.
So
Okay,
this
I'm just
I
taking the
is
same
this formula is
example
used when the
for
character exists in the pattern, right?
not exist,
If
not exist.
if it not exists, then we'll do that. We'll just shift.
Okay. Sorry. Yeah, if it is exist, okay. And this is for
Yeah,
not exist.
this
In that
this is
case,
this one is clear. Else one is very clear because you're just shifting the
yeah,
whole thing by.
yeah, we are shifting the whole things. Okay, so the last key. Okay, so yeah, if it is not exist, so there is no meaning to check the last. Okay, if it is exist, so what will be the situation for this one? Okay, so we can take an example. So for example, to okay, so let's see what is the situation. So pattern is not matched. Okay. Okay, so for example, A, B, B, A, B, C. Okay, and here we are just checking that A, B, A, B. I'm just taking this as a C. Okay, pattern is equal to C. So in that case, for example, this character is matched, this is matched, this is matched, this is matched, this is matched. Okay, this is not matched. So in that case, what will be the value of J? 0.
Right.
Okay, and 0. Okay, and what is the last value
But
of?
J is the last, the length of the pattern, right, sir? So we are matching from the.
No, we are starting from the last index, na? So after
Okay.
reducing, so
Yes.
it will become 0. At this position, we are not matching. Okay,
Right.
so J equal to 0. And what is the value of B? B is 3. Sorry, A. Okay, B is 3. Now we are getting this B equal to 3. Okay, so just put this. Oh yeah. Okay. So in that case, here you can see that what will be the next position. So in that case, you can see we will shift one position because our B is exist. Last index is here, but in our text, this is the last character which are not matched. So there is no meaning to shift to the this side. Okay, we will always shift on to the right side of the pattern.
Okay.
So in that case, we are decide. So in that case, we will shift based on this value. So here you can see that what is the I value is 0, for example, plus max j minus. So for example, j is 0 minus what is the last value 3. Okay, and comma 1. So if any time we are getting this minus value, so minus 2 comma 1, so we don't want to shift to the left side. Okay, so in that case we will shift one position. At any time we are getting this minus value, so that means uh, the last index we are getting after this position. For example, this v is not matched here, but the last character we are getting after
It's clear,
this.
sir.
Okay,
One is
no.
clear, right?
So because of that,
Can you take this example above also, sir? This T A B C, just above this.
what example?
This where you put this T A B C B C B A is the text, and pattern is A B A B C.
This one.
Yes, sir.
Okay.
Because here C is coming outwards. So
So same thing. So C is not matched, B is not matched. So now the C value. Okay. So what is the value of J here? J
2,
value is 2. Okay. And after that, what we are getting, the value for C. C value is 4. Okay. Last value of C is 4.
right?
Okay. So 2 minus 4.
4.
Okay. So same things. In that case, at
Same.
any time we are getting,
Okay. Anything negative. Okay. Got
hmm,
it, sir.
we will shift one position.
One position. Right.
Okay. So at any time our last index is coming after the compare index. Okay. So in that case we will shift only one position. Because of that we are taking this formula.
But sir, if I think about it, if the text is a pretty long string, then it will always be one, right, sir? Because the last index will always be a bigger value.
No, no, this is not true. So for this, I am just taking this simple 3 character example. Okay. So in that, so what
No,
example
sir.
you are thinking? Can
Basically,
you
I'm saying
tell
that
me?
if suppose I have three distinct values in a text, which is quite long.
Hmm.
Suppose if I have 20 values in that,
Hmm.
and three are
Okay.
distinct,
Okay.
ABC basically, and then I have a small text of 5 characters.
Okay.
So the last dictionary will always have bigger values, and it will
Yes. So
always give me negative when I do this. And finally, all my maxes would be one.
yeah, so in that case you have to shift only one position. So
One position,
there,
right, sir?
yeah, so these are some cases. So because of that, the Boyer-Murray algorithm is also takes m into n times
Yeah,
in worst case.
yeah, yes, sir.
Okay.
So one more doubt, sir, here.
Hmm.
So this shifting is actually the pattern is not aligning by the shifting because we are shifting I by 1. So we are just
Yes.
shifting the pointer of the text by 1 in this
Yes.
case where it's a negative case.
Yes. Okay.
Okay. So,
But we are
okay.
also deciding the j value based on the I. Okay. So j plus I in that way.
Okay.
Okay. So
o-
because of that, this j will also shift if we are increasing this I.
Okay. Right, sir.
So now
Okay.
could you go back to the code just to
Mhm.
finally wrap up that? Yeah.
Yeah. So here you can see that if the character is exist, so we are taking the max value of this and 1. If we are getting negative value here or 0 value here, then we will take the 1 shifting. Otherwise, if character is not exist, so we are simply ignore shifting by all these characters. So I plus j plus 1.
Okay, so we move total distance of the pattern basically.
Yes. So for example, this j value is coming and this. So for example, A, B, D. Okay, so it's A, B, D, and B, C. Pattern is like this: A, B, A, B, C. Okay, so here this is not matched. Now this is not matched, and this is also not exist. So what is the position of J is 2, and value is I equal to 0. So we will completely shift I plus j plus 1. So 0 plus 2 plus 1. That means 3 position we will shift directly. Okay, so after this character, we will move like here
Okay,
A,
sir. Yeah,
B,
got it.
B, C. Okay, So these things we are doing, and the same things, the worst case we will also get. So what will be the worst case for the Boyer Murray? So same things we can decide. So like the string is a in that way. Okay, and we are taking like simply b a.
Will be the same as the reverse
Hmm.
knife case.
Yes. So
Same.
here the last index of this is 0. Okay, when the we are not getting, so same things here, this is match, this is match, this is match, this character is not match. So at this time, at the character is not match, we will get the negative value, so we will shift one position only, b a in that. So this is the similar of the naive approach. So m into n for this is also, but this type of condition we will get in the rarely. So we can say that we can improve our complexity in most of the cases using this Boyer-Murray algorithm. We can skip many uh, positions. Okay, so this code is clear.
Clear, sir.
Yeah. Okay, so the complexity of first case, you can see this. This is also n into m. So the condition is also given. Text of. Now the next algorithm is Raven-Karp algorithm. Okay, so in Raven-Karp algorithm, basically we use the approach for number comparison. So number comparison means we can convert our string into a number, and using the arithmetic operation, we can compare our strings. So how we can compare these things? So for example, we are just simply assuming that after converting a string into a number, so number we can simply uh, character we can convert into a number in that way. For example, we can simply assign a b c, each character is a number like this, 1 2 3 d equal to 4, in that way. So after when we are getting any strings, so based on this dictionary we can convert into a number. So
Sir,
after,
we require to start with zero, no? Because we are doing some modulus something there in this.
yeah, we can take any numbers here.
Not,
Our
not
yeah,
with zero. We require to start with zero and
yeah, you can take 0 also. Okay, 1 2 3. Yeah, so main purpose is we want to convert our string into a number. So after converting this, we can perform arithmetic operation for comparison. So how we can perform these things? So for example, in this algorithm, you can see that after converting our text into a number, this is our numeric strings. Okay, same things for the this is p pattern. This is text.
So one doubt here. So the text cannot exceed more than 9. You can't have A, B, C, D, E, F, G, H, the whole alphabets, because there'll be 26.
Yeah, so we can decide two value for each character, like this is 0 1 for the a. So based on that value you
Okay.
can assign the numbers. Okay, so here we are just taking one example. So for conversion you can use any algorithms. So you can decide the two numeric value for each character. Okay, in that way, decimal value. So but after converting this number, how we can perform our matchings? Okay, so for example here, uh, this is the part. So 2 3, this is an example. 1 second.
and if it is 2 3 like BC is equivalent to Y, na, sir? XYZ, that is also 23 and this is also 2 and 3. If
No,
it is
I am not explaining the algorithm for conversion. I am just taking the example for the numeric comparison. Okay, for conversion you can use any algorithm. So for if you have a 26 character, you can decide how you can give the decimal value for that. Okay, so each character you can decide. So for example, you can start the value in the two characters. Okay, so you can assign the a equal to like this a 10, b equal to 11, in that way. Okay, so 21 22, in that way. So here the value is not repeating for any character.
Right, right. Thank you.
Okay. So after conversion of this text into a numeric value, so we can perform this Raven-Karp algorithm. So for Raven-Karp algorithm, how we can perform. So for example, if we have a pattern, if we have a text and pattern, so we can simply like this 2 3 3 1 6 2 1 5 3 2 1 in that way. Okay, and our pattern is 23. So we can simply take any q value for this. So q we are taking for the calculate the mod value for this. So what is the mod value? What is the reminder value for this? So 23. If we are, so for example, if we are taking q value, so we can take generally this prime value. So for example, if you are taking 11, okay, so we can simply calculate the mod value. So what will be the reminder for this 23 mod 11? This is
One.
1.
One,
Okay,
one.
1. So we can decide what is the reminder value for this pattern. Okay, this is 1. After that, so what is the length of this p is 2. So we will take the length of our pattern in our text. Okay, we will just select that this value. So 2 3. So we are taking 2 3. Then we will also use the q value for the same things. First we will simply calculate the reminder value for this. So 11 we will get 1.
But sir, how do you get the Q value? I mean, how did you decide on the value 11?
Here we can take any prime value for that. Okay, so this is depends on us.
Okay.
So this, if we take the large value, so q value is basically we choose to reduce the false positive. Okay, so false positive, I will explain this term also. So first thing, okay, so here we can choose any.
Okay, sir.
Okay, but generally we choose the prime value.
Okay.
Okay. So 23, here we are getting, so for example, the same length value 2. Okay, so we are getting 23. So we will just simply calculate this reminder value for this 23. If we are getting the same reminder which we have already calculated for pattern 1. Okay, so for this 23, we are getting the same reminder 1. So at any time we are getting the same reminder. So then we will compare our strings.
Sir, and the pattern is always taken all together. Like you have taken 23 altogether rather than taking 2 and 3. So it
Yeah,
is
we will calculate the completely. We
okay. So if
will,
it was 2 3 1, you would have taken all of them
yeah,
together.
2 3 1. We will
Okay.
take
Okay, sir.
like this 11.
Fine, sir.
Okay, so but in the text we will select the value for equal to the length of pattern.
Yes, sir.
Okay, so here we are just selecting the length of 2. So 23 we are getting. So we will calculate the same reminder value for this part, and we will getting the 1. Okay, so same value 1 we are getting. So for pattern we are getting 1. In the text we are also getting 1. At any time we are getting the same reminder value, we will think about that this part can be matched. Okay, but we cannot sure for that. Okay, because reminder value can be same reminder value can be generated for two or more different value. Okay, so this is the first filter. We can see that if reminder is same, we can think that this part can be matched. Then we will perform the uh, one by one matching. So we will check that this 23 is actual equal to this 23 or not.
Clear, sir.
Okay, and if this is matched, so we will store the position for this. So we can store this 0 index. After that we will shift one position. Now this is 33. Okay, now we will calculate this reminder 11. Now we are getting here 0. At any time if the reminder is different, so there is no need to compare this value. Okay, because the reminder is different, no need to check this, no need to compare this value. Same things we will shift again 31. So 31, then 11 we are getting the large value. Okay, so 9 I think. Okay, so this reminder you can see that this is not matched, so we will skip the matching for these things. 16 will get the 4, sorry 5. Okay, this is also not matched. Now here you can see that 55 and then you get 7, this is also not matched. 21, this is 9, not matched. 15, 4, not matched. So this is also not matched. 44, 6 to 8. 23, here you can see that okay, so this is the same value. Okay, 23, so this part you will get 1, and after getting the same reminder you can compare the value also. So 23 is equal to 23, so this part is matched.
So if
Now
this was 34, then
hmm,
again I'll get 1
yeah, so
instead of
that
33.
yeah, for example, this is 34. So in that
That
case
is the false
yeah,
positive.
yeah, so if you are getting the same reminder, you are getting here 1, but the value is not same. Because of that we cannot sure after get matching the reminder. Okay, so after matching the reminder we will also check that the value is same or not. Okay, so based on that we can decide the matching.
So we have two filters. One is
Hmm.
same parameter, and then the values are same.
Then yeah, we will perform the matching after we are getting the same reminder.
Okay.
Otherwise we will skip completely to that part. So this is called the false positive. Here the reminder are same but the value are not matched. So that is called the false positive or spurious match, these things. So that logic we are using here. So same things if our pattern is long, for example, this is like 416. Okay, so in that case you can calculate the reminder for this level. If you are getting any x value, then you can select the same length value from here. If the value reminder is not matched, you can skip. There's no need to check the value comparison. Okay, so in that case you can think that we are not uh, performing this string comparison one by one character. Okay, here we are simply just comparing this reminder value, or we are simply performing this arithmetic operation that are uh, unit operation. Okay, so constant operation. So these things we are performing in this code. Now how we are getting this value, how we are just filtering this two value each time. So that things we are performing some using this math operations. So in this code you can see this position list, this is the output list, and in the next is this is the initialization of num p. So this is for text, this is for pattern. Okay, both are 0. And here you can see that we are just using this formula to calculate the value of the length of the pattern length. Okay, so for example in this case we have a 23 in our pattern. Okay, and in our text, because we are passing the strings here. Okay, and our text is like this 2 3 3 3 2 in that way. So you can you can check the value. So for I in range of len of p, so what is the len of p is 2. Okay, so this loop will perform 2 times 0 and 1. Okay, so in that case, first case we are getting this for num t. That means we are just picking the value from the text of the length p. Okay, so how we are calculating this value? So we are just using this 10. So initial this num t is 0. So 10 into 0 plus int of ti. So ti 0. So what is the first character of this t? 2. Okay, so 2. That means in the first case we are getting 2 in num t. In the next iteration, so the what is the previous values of num t is 2, 10 into 2 plus now I equal to 1. So we are just taking the second character 3. So in that case we are just picking this 23 from our text. That means we are just getting this 2 value from our text using this for loop. Okay, and same things we are using for pattern. We are also scanning this pattern and we are taking the value. So after we're getting this value, we are simply just checking this num of t equal to num of p, because these both value are integer value. So we are performing this equal things. Okay, if both value are same, then we are simply appending. So this is only for the first case.
This is if there's a match, complete match.
Yeah, complete match.
Okay.
Mm,
But then it has to
okay.
be same length also.
Okay, so in this, in this code, we are not using that Q concept here. Okay, so
Yes, sir.
reminder concept
Q
we are
is
not
not
there.
there here.
Yeah, so here we are just performing in the different way.
So you're equating both the numbers. That's it, right, sir? Here.
Yes, yes, we are just picking the numbers and we are just directly comparing this.
So what is this code for if num t is equal to num p? That means they are of equal length and they are matching. The numbers are matching.
No, no, the not length, the value.
The
Both are
value.
integer
Sorry,
value.
yeah,
Yeah,
yeah, because both are integer. Right,
yeah,
right.
both are integer value. Here we are just simply comparing both value. Okay, so
Okay.
this part is only comparing the first case. So this is comparing only for this 23 and 23. So after, so how we will perform this shifting? So that part we are performing here. Okay, so this is the only first case. And for the next part here, we are starting the I equal to 1. Because, okay, so first we have already, for this position, we have already picked up. In the second position, we are performing here. So, okay, because of that, we are taking this I equal to 1. Okay, so in that case, you can see in the len of t, yeah, so we will start from the 1 and then we are moving to the last position, last
So
index
we are
minus.
starting from 1 because we've already appended 0 because they are equal, right, sir?
We have already checked this part.
Yeah.
Okay. Zero starting part we have already checked first
Okay.
in this part because
So
of the
if
after.
the starting part was not equal, even then
Yes, yes, that will remain same.
it will remain same, right, sir?
So it is not depend on the equality matching these things. Here we have simply performed the one matching directly in the this operation. After that, we are for shifting we are using this loop.
Okay.
Okay, so because of that we are starting from the first index because in the zeroth index we have already compared in the previous part.
So this if
So
condition line 7 code, I'm not clear. Okay.
this part,
Yes, sir.
okay, so okay, I'm just taking this second.
Actually, we are taking one string and making it as a number,
Mm.
and
That's
we
what I
are
was
comparing
saying.
that number.
Yeah.
Yeah, that is that seventh one.
So here we are simply for example t equal to 2 3 like 1 3 4 1 5. Okay, so and pattern is 23. Okay, so we want to just compare of this. So here initial case you can see that num t equal to 0 and num p equal to also 0. So in this first iteration, this part, so we are simply comparing the first possible value for in text and pattern. So how we are calculating? So in the what is the length of this pattern is 2. Okay, so this loop will run 2 times. For one is 0 and second is 1. Clear this part?
Right, sir. Clear.
Okay. After that, we are simply calculating the what is the value in num in the text of two length. First, okay. First two length value we are finding in the text using this loop.
Clear, sir. It's clear.
Okay. So after completing this loop, we will get the first value num t equal to 23 from the text. Okay, and second numpy from the pattern. It's also 23.
Clear,
And
sir.
here both are the integer value. We are simply comparing them. Numt equal to numpy.
Clear.
So
Thank
in
you.
that case, if this value are matched, then we are simply appending the zero index in our
0.
output
Right.
list. Okay,
Right.
so that means we have simply compare these part till now.
Right. Clear, sir.
After that, we want to perform the shifting. Then we
Clear,
want to
sir.
pick this in that way. Okay. So for this part, we are performing this for loop, and here now we are starting from the one index because the zero index part we have already completed. So because of that, we starting from the one index, and we want to move to the till here. Okay, this 0 1 2 3 4 5 6. Okay, so we will move to till here. So because of that, we are taking this condition len of t minus len of p plus 1. And once again we are calculating this num t value. So using this formula you will get the next 2-digit value in our text. So how you will calculate, because in the last num t is 23 minus t I minus 1. So t I is now 1 and 1 minus 1 is 0, so that is now 2. Okay, into 10 to the power ln of p minus 1. So ln of p is 2, 2 minus 1 is 1. So you are getting 2 into 10. So okay, so 2 10 1 20. Okay, so 23 minus 20, so now you are getting 3. Okay, in the first iteration. Okay, so no, not the first iteration, the first line. In the second line you are simply using this num t, and num t equal to 10 into now 3 plus next. Okay, so int t I ln of p minus 1. So, okay, so ln of p minus 1 is 1, then I is now 1, so 1 plus 1 is 2. So that means t2, that is this one, 2 index. Okay, so 1. So 30 plus 1 is 31. That means we are just finding out the second 2-digit number in our text using this numerical formula. Okay, so now we are getting this 31. Now pattern numpy will always remain same. Okay, so we are not changing this part, so we will always pick this numpy. And now here you can see that we are simply comparison numpty equal to numpy. If the value are matched, so here now we are simply directly checking the value.
Sir, how do we
So
come up with this formula? Because it's like it looks like too complex. And
yeah, you
it
can also find another formula if you are, you can simply took as a problem.
and would this remain the same for any string, sir?
So
Yeah,
that
that will remain the
modulus
same.
It will
formula
remain
you
the same
use was
because
much simpler.
No, sir,
yeah,
even
modulus is
I
simpler. Yes.
Yeah, that approach is much similar.
no, sir,
So that approach we can also use. We can also write our code in that way, in the modulus way. So actually, algorithm use the same concept, the modulus concept. Okay. So here we are using some different approach. Uh, Otherwise, okay. So I'm looking the algorithm part once. So in algorithm, okay,
So this algorithm is only for numerical comparison.
yes, for numerical comparison. But we are converting our text into a number. Okay, so we can convert our text into a number
Okay,
format,
so
then we
first
can use this.
converting text to number, that is any kind of conversion that we are not discussing here,
Ye-
right?
Uh, yeah, that
Okay.
we are not discussing. So this is the next step after
Okay.
conversion.
But sir, here, I mean, you have taken one digit at a time because your sigma is only 0 to 9. But like the alphabets are 26, so we'll have double digit
Mhm.
numbers. In such a case, there will be a lot of change, right, sir?
Then you
Uh,
can't have 10 to the power, sir. Then it'll this
Ye-
whole thing will change.
Yeah, and we can't identify which one is a double digit, which is a single digit.
yeah, so in that case, we have to change the approach.
yeah, instead of 10 power 2 into ln of p minus 1, it will come. So 2 digits, 10 power 2 into, it is 3 digits, 10 power 3 into, like that.
But how do we identify where it is one digit and where it is double digit?
I think the 10 or like it will be coming from the number of alphabets. So if it is a letters, it will be 26.
Right. Yeah.
So instead of 10, it should be 26 in that
26
case.
to the power, right?
Yeah.
Oh, okay, okay, that way, okay, fine.
Yeah, so based on that, we have to change our algorithm also. That, so this is the basic algorithm how we can compare the numeric things. Okay, so for conversion, you can use any algorithm. So based on that algorithm, we have also changed this concept. Okay, so this is Levin car. Uh, so I think, yeah, this is discussed here. This more Q part. Okay, so modulo Q, this part. So The implementation is given in the different way, but we can also perform using this modular things. Okay. So here also in the worst case for journal alphabets is also n into m. So what is the case is here? So in that case, for example, if every time we are getting the false positive, okay, so then in case we have to also perform the matching in the text and pattern. So that becomes the for worst case for this 7-carp algorithm. Okay. Otherwise, we can also improve this complexity. So that way, here you can see that the overall time is n plus m or before n. If m is much lesser than this n. Okay. So next algorithm is KMP algorithm. So before KMP algorithm, so we will discuss the suffix and prefix part. What is suffix and prefix? You know the suffix and prefix? If
Yes, sir.
any strings, so for example, A, B, A, B, okay. So generally we say use the suffix things for this is a suffix. Okay, so A, B is also suffix. A, B, A is also sorry prefix. Okay, so not
Prefix,
suffix.
yes.
Yeah, this is prefix. This is prefix. This is also prefix. A, B, A, B. This is also prefix. But we generally not take complete as a prefix. Okay, prefix means the pre part of our any strings. So same things we can take suffix. Okay, so a b a b a. So we can see that this is a is a suffix. So same b a is also a suffix. A b a is also a suffix. So the same thing that way. A b a b. Okay, so using the suffix and prefix things, so that concept is used in the KMP algorithms. So for example, if any strings, if we are comparing, so like this, so a b a b, if any pattern contains this pattern, okay, and our text is also like this, so t equal to, so a b, okay, a c. Okay, so in that pattern you can see that here this AB part is repeated, and this AB is so in this complete pattern we can see that here this AB. Okay, so one AB and AB B, no, not that. Yeah, so this is the maximum length of, so 2 we can decide. So what is the maximum length of the suffix which is equal to the prefix in our pattern? So you can see that the 2. Okay, so because AB, if you find out the prefix thing, so A is a prefix, but in the last you can see that this is
We
not
are
a prefix.
saying suffix and prefix for P only.
Yes, for
For
P.
Yes, yes, it is 2. Right.
2. Okay, so the longest, so what is the maximum length of the suffix which is also a prefix for that pattern? Okay, so that information we can store. So for example, in that case you can see that the maximum length of this prefix or suffix is 2, which are equal. Okay, so how we can use this this information to skip our uh, matching part? So for example, if we are starting comparison from this text and pattern, so that you can see that this first character is matched, okay, second character is matched, third is also matched, but at any time you can see that this AB is matched. Now this part is repeated from here. Okay, so at any time this C is not matched. So how we can decide the shifting part based on this uh, maximum length of suffix or prefix which are equal, because this part is already matched, okay, in our text. Okay, so that means if this part is already matched in this part, so we can say that this part is also matched for this. because both are equal.
Right, sir.
Okay, so based on that, this value, we can decide the shifting. If in the next part A and C, here the characters are not matched, so we will shift our pattern. uh, so after matching, so after so character is not comparison matched here. So based on, okay, so for what we have, 1 second. Hmm, no, 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 so confusion is there. We got thumbs. So this is okay. Shift. Okay, so we are performing comparison from start. 1 second. I have to check the code. 0 0 dynamic S1. We are starting the comparison from. So we can skip these things. Oh, we can decide. Next part. Okay, I have to take on another example for that. 1 second. Scan T from the beginning. J is the next position in T. K is currently matched position in P. T J equal to extend the match. Update match prefix. We reach the end. The while loop no match. Okay, so I'm confused now. So the part is already matched. We can say pattern that way. Yeah, I'm just explaining from the previous things. Sorry, C. So for example, this is C, this is B, now A, B. Okay, so A, B, A, B. So this is C. Yeah. So in that case, you can see that if this is matched, this is matched, this is matched, this is not matched. Okay. So here you can see that in the pattern, if we know that the this first two characters are also similar to this last two character. So in that case, if we are finding out this last unmatched things, okay, so we can simply decide that the shifting based on this value. So for example, these two value are matched with this two value. So that means this two value is also matched with this two value, starting two value. Okay, so we can directly shift in two position based on decide this. So A B A B in that way. So we will simply shift in that way. So the prefix part will come uh, on the below of this suffix matched part, which we have already compared. So there is no need to compare again. So that part. So in that case, we are shifting accordingly. Pattern comparison. The text. Okay, so but in the algorithms. Okay, so I'm just taking first things. First things, how we can calculate this this prefix and suffix value. Okay, so that is the first part. Then we will take an example using the code. So this is the first part. This is called the KMP fail function. Here we are simply calculating the this suffix and prefix maximum things. So how we can calculate this? So I'm just taking this example ABC AA BCA. So ABC ABC A BCA. Okay, so for example, if we have this pattern P, so for each part. Okay, so for each part of the pattern, we can decide that what part of the suffix and what are the part of the prefix are matched, and what is the maximum length. So okay, so we can calculate the KMP fail function for that, and this is a list actually, and we will decide the value for each part of this pattern. So for example, the total number of characters are 7. Okay, so one no, to eight, total number of characters 8. So that means index is 0, 1, 2, 3, 4, 5, 6, 7. And we will initialize this fail function. So I'm just taking the name of this list is fail, and we are just initializing by 0. Okay, so after taking this, we will just traverse this p list, and we will check that. So for the single characters, okay, so there is no prefix or there is no suffix for that, okay, because this is 0. So this is a single character, so we will remain same as a 0 till now. Now for the second part, okay, so this ab, if we are just taking this ab part from this pattern, so can you tell me what is the maximum length of the suffix which are also equal to a prefix?
0, it will be 0 in this.
0, no? So okay, so in that case we will remain the same 0. In the next part we will increase the length of this ABC. Now what is the maximum length? 0.
It's 0.
Okay, so we will remain same. In the next we are taking one more character, A B C A. So what is the maximum length of here? So prefix is A and suffix is A.
A,
This is
right.
only the one possible. So
One.
here you can say that the one length is there. So we will update here now 1. Okay. Now the next case, so A B C A A. In this string, what is the maximum length? 1.
1, right.
Okay. So we will update 1 here. In the next, now A B C A B. Now tell me
Now
what is the
it's
maximum length?
2 because A, B.
Yes. So what? Yeah. What is the maximum length of the prefix which are also a suffix? This is 2. So we will update 2 here. Okay. So now next we are also adding one more, A B C A B, and we are adding C. Now you can
3.
see that length is 3. A B C A B C. So we will update 3. Okay, now we are adding also one more. So A B C A B C A. Now here A B C A or A B C A. Correct? 4. So we will update 4. So our fail function actually calculating this value. In
So
the
every time prefix and the suffix required to match each other, right?
uh,
Both required to
every
be
time
equal.
means
Suffix and prefix.
yes, yeah, we are increasing this value when we are getting the equality in prefix and suffix. And what is the length of this? Okay, so till now, for example, this how we are deciding the value for this 2 index. So we are just considering this string before 0 to 2. So in that way we are calculating this fail function. So we will use this information to decide the shifting position. So and we are performing this fail function in what is the length of this p. Okay, in the for example this is n, so we are performing this operation in big O n time. Okay, so how we can perform this? This is also one problem. So how you can perform this in big O n time? This part. Okay, so here one code is given. Okay, I'm just explaining the code.
So this fail is basically giving a list for that particular index in the list. What is the longest length of the suffix and prefix? That's
Yes, which are equal.
okay.
Okay, so the code is given here for this part. If you see that how we are calculating these things, so we are simply calculating the length of p, then we are simply assigning a list by 0 value. Okay, so for example for this is all 0, 4 5 6 7 8. Okay, After that, we are simply taking this j and k by j is 1 and k is 0. We are taking this j equal to 1 because the first character there is no need to calculate. Okay, so here this is a, b, c, a, and a, b, c, a. Okay, so for first character there is no need to check. So because of that, we are taking this j equal to 1 directly. So that means we are calculating from here. So j, this is value is j, and k
No, but what
value
are
is
these pointers, J and K? It is pointing to the same
no,
bit.
no. So no, actually, j is representing a last character, and k is representing a first character to checking the suffix and prefix.
Okay.
Okay, so this is the condition while j is less than equal to m. So that means we are taking a while loop of the length m, and inside the length we are just simply performing this if, elif, and else condition. So you can see that the complexity of this part is uh, big of m. If length of this pattern is m, so complexity will also remain the big of m. So how we are performing this? So if pj, so you can see that the k is pointing to the 0, so k is pointing to here 0, and so j is pointing to the b. If pj and pk are same, okay, so in that case here basically we are using this dp concept little bit. Okay, so pj and pk is meshed. Okay, so if in the first case you can see that this is not meshed, so this first condition is not true, then we will move to this lf part, then check that if k is greater than 0. If k is greater than 0, in the first case k is 0. Okay, so I'm also written the index 0, 1, 2, 3, sorry, 1, 2, 3, 4, 5, 6, 7. So k is
In
0
the
now.
first case, K is not greater than 0. It's 0 only.
Yeah, so this condition is also not true. Now we are moving to the else part. So that means it's the first value is not matched with this, so we will skip, we will increase the j only.
Okay.
Okay, so that means this value is not changed. Okay, because till now we have not found any prefix or suffix similarity. So in the next iteration, so now the j is pointing to the c and k is pointing to the a. So same things we will repeat again. Now the value are not matched, c and a. So that means this condition is once again true, and in that case we will increase j1 by 1.
So K basically is keeping track of the prefix, right, sir?
Yes, prefix, actually k is checking for the prefix part and j is checking for the suffix part.
Okay, sir.
Okay, so now you can see that how we can update. Okay, so in the next iteration, so a b c a, now j is pointing to this a. Okay, in that case you can see that the pj and pk are same.
Right.
So same time we will use this fail j equal to k plus 1. So we are using this, we are storing this fail j equal to k plus 1, and so now k is 0 and k plus 1 is 1. So we will update this is 1.
Right.
Okay, now j and k both we are increasing by 1. This time we are increasing by 1 because we have already found till now one similar character. Okay, so now we have shifted k at the first and j here, because there is a chance to found the two similar value as a suffix and prefix. Because of that we have increased this. If value is not matched, then we will reset again to the previous part. Okay, so here you can see that in the next iteration we are now j is pointing to this a, and
K is
uh,
B.
okay, k is b. Yes, k is b.
It's not
Value
mentioned.
are not matched, so that means we are coming at this position, and here you can see that k is greater than equal to 0. Okay,
Right. Right.
so we are just updating this k value based on this fail k equal to fail of k minus 1. So what is the k value is 1, and we are just checking the what is the fail value of this k minus 1, and that means 0. So this is 0. That means our k will come back to the first position. Okay,
Okay.
because here this a we are getting, Okay, so at any time we are getting similarity of this. B is not similar to this part. So that means uh, we cannot find the continuity of the matching in the prefix and suffix. We have to check from the starting position again. Okay, so okay, so we just move to the next position. So in that case, we are also okay. So we are not increasing anything. No, no, 1 second. Yeah, so in that case, J. Okay, so J is okay. So now J is remains same. Now we are checking for this A and A. Now we have shifted K to one position left, and now we are checking again. We are not shifting J. So J now is matched with this K. Okay, that means we are checking the last character of the suffix position in the last character of the strings and the first character of the strings now, because the second value is not matched. Okay, so A and A is matched now.
So it'll
So
be 1 again.
yeah, so in that case this value is matched. So now K will reset to 0, and we are using this 0 plus 1 is 1. So we will update by 1. Okay, now in the next case you can think that so
So
okay,
now
so
K will again move to 1.
yes,
So
now
it's
K,
moving back and forth,
yes, K and J is now here.
moving to the B.
Now in the next iteration you can find out this B is matched.
Mashed, right?
So there is no need to check the previous part, because till now we have found out that this A is also matched with this A. Okay, so if we are repeatedly getting the similarity, so we will use the previous value for A. So in the next case we will use the what is the K value, then we will increment by 1.
Right.
Okay, so in the same case, fail J is equal to K plus 1. That means two continuous characters we are getting similar. So in that case, we will update by this uh, K plus 1. So K is now 1, 1 plus 1 is 2. So this will become 2. Okay, now in that case, we will also increase this K here and J here. Now you can see that C and C is matched. So same things we will update by K plus 1. So K is now 2, 2 plus 1 is 3. Okay, we will increase by this K here and J here. Now A is also matched this A. So once again, 3 plus 1 is 4. So this 3 1. Okay, so K is pointing to this 3, 3 plus 1 is 4.
This is clear, sir, because actually the pattern is also matching. ABC, the suffix and prefix
Yeah.
also matching. BCA
Yeah,
and
but
BCA.
here actually we are why we are using this approach, because we want to reduce the complexity for this. Otherwise, we can perform this using a naive approach, and then the
So the
complexity will.
problem is, this is clear. Once you have explained the code, it is clear. But to create a code like this, it is I don't know. Someone has to really sit down and work to add K and then reduce K, and then it's very,
So
I don't know.
actually, yeah, so that are the algorithm actually, and you can. So here the target is to perform in big O M time. Because of that, we are using this approach. Otherwise, we can easily perform this task by the naive approach, but the complexity will become large. Okay,
Right.
because we want to reduce the complexity for overall code of KMP algorithm. So because of that, we are performing this is big O of M time. So because of that, we are taking this this is a clever way to
No,
performing this.
that I agree, but one has to keep practicing this. I mean, this cannot be actually this code to recall is very difficult. Because one has to actually keep practicing, only then only one can.
Even after seeing the code, it is like difficult to reproduce, right?
Right.
Yeah, but actually for these type of algorithm, we should know the concept, what we are doing, what we are actually calculating this. So that should be the clear things.
But sir, even if the concept is clear, we somehow lose track in between. I mean, I may write the 3, 4 lines of code properly, and then somehow, somewhere, I lose the track.
Yeah, code part actually, yeah, that is little bit tricky part, because here we are using some dynamic programming concept. Here we are using the previous calculated value. So dynamic programming is also a little bit tricky things. You have to do the practice for the DP problems, then you will get this solution.
And sir, what is exactly the output of this list? What it exactly means? 0 0 0 1 1 2 2.
Yeah, that part I have explained now here. These things. So every value is representing. So for example, this position, if we are checking this one, so that means till here. Okay, so this string contains a one length suffix, which is also matched with prefix. Okay, so this
Longest prefix suffix,
yes,
basically.
yes.
Longest prefix.
Okay. Okay, sir.
Okay, if you see this two value, that means till here. This the longest suffix is also equal to this prefix.
Okay,
Yeah.
sir.
Okay, so that things we are calculating.
So, sir, here we are comparing the pattern with the pattern, is it? Right, sir?
Yes, pattern. Yeah, we are performing only for the pattern. This
Only
things.
for the pattern.
Okay, so
Sir, in this we have found only suffix and prefix, whereas we didn't find that text with pattern. We didn't done, right?
no, so this is the one part of the algorithm. I have just explained the one part of the algorithms. Now we are using this approach in the KMP algorithms for string matching. Now come to this point, implementation of KMP algorithm. So here you can see that this things we are using in this KMP algorithm. Okay, so this is KMP fail function. I am just explaining that how we are calculating this KMP function and what it is represent. So after calculating this, we are just using inside this KMP.
So why are we calling it fail? Because it should actually be.
Yeah, I had the same question. Why is it fail?
Okay, so fail things. Oh, I also not think about that. Fail function means actually at any time the value is not matched. Uh, so
Should be called suffix prefix match, something like that.
yeah, we can give any name. Yeah,
Okay.
but in the lecture, I think sir use this fail function. Okay. Okay, so come to the this KMP things and how we are getting the benefit for this KMP function. That part actually I have stuck that. So this similarity things, I'm not getting the exact. It's a setting. So for example, I'm taking this P, A, B, C. A. So here this is the okay. And text is the piece of text. So if I'm taking this text, so like this A, B.
So I just want to ask something.
Mm-hmm.
This the fail function, what you said. So it is the longest suffix and prefix.
Mm-hmm.
So is it because that in the P, if we find that this is already existing,
Yes.
so that pattern is there, and we have different the fail dictionary or the fail the fail
Function.
function has different patterns, different length patterns, which can be compared to this text. So is it that if we have some partial match, then we can see that if the next one is matching and then directly go to that particular
Yeah. So same things I'm saying now. If the same part is repeated in our pattern, and if any time we are finding the not matched part. So in this example, if you see that if this part is already matched, okay, this
yes,
part. Okay, so in the next part, if we are getting the not similarity, like this A,
then
B,
we can
C.
carry what is matched to
Yes.
compare with something else and which brings a
Hmm.
match. So is that the purpose of this?
But the
So
shifting things I have confused now. So, which part we have to shift? Okay, so A, B, C. This is matched with this one. A, B, C. So this A, B till now is already compared. Okay. Okay, I have to look the code now. So I think to so the first things is simply we are taking NM match append calculating the fail function here. This is now less JK. If the characters TJ and so J and K are the first character. So the first condition is that we are taking this condition J. We are comparing the our so TJ actually we are taking TJ J, okay, and K is we are deciding based on this fail function. Okay, so in the pattern we have to shift the position. Okay, so for example, sorry. So for example, if I'm taking this A B, but it also makes these things. Okay, so I think okay, so we are using this in that way. So A B C, like this C. So for example, A B C D in that way. Okay. So for example, this is our text and this is pattern. No, 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 no. This is A B A. Okay, so this is A. So in that case, so for example, if this is matched, and this is also okay. So here A. So this is text, for example, and this AB is matched with this AB. Okay. So in that case, that means this AB is also matched this AB. If this is matched with the first part, we can see that this is also matched with this remaining part. Okay. In the next position, if we are not finding the similarity, so we can shift our text position, or we can see that we are shifting. D here. Not just totally. Okay. So here, for example, J equal to PK, this is matched. If K equal to M minus 1, that means all characters are matched. So in that case, we are appending the solution in our result list, and we are resetting K equal to 0, and then we are also J equal to J minus M plus 2. If the pattern are matched completely, then we are storing the result in match list and resetting K equal to 0, and we are also take this J equal to J minus M plus 2. So I think that we will get the one position shifting. Else, if the characters are not matched, we are increasing J and K both. Okay, so I'm just taking the example till now here. So for the same, this one. Okay, I have calculated the A B C A B C A. So this is for example pattern A B C, or I'm taking A B C A B C. And what is the fail function for that is A, B, C, A, B, C. 0, 0, 0, 1, 2, 3. Okay, so now this is pattern. Yeah, now the text. A, B, C, A, B, C, B, C, A. Okay, so first character is mesh, second is mesh. So this is taking we are taking k equal to 0 and j equal to here. If both are meshed, we are increasing both by 1, and in that case all value are meshed. So this is the first case of the code. Okay, if the all elements are meshed, that means at any time if we are reaching this k equal to m minus 1, so here m is the size of this k. So if at any time we are reaching this position, that means our complete pattern is now matched. So we will simply append the solution and we will reset k equal to 0, and j we are reducing by this using j minus m plus 2. So in this case, what is this k value is 1 2 3 4 5 6. So 0 1 2 3 4 5. So now the k value is 5 and j value is also 0 1 2 3 4 5 6. 15 16. So j is also 5. So 5 minus 5. J equal to j minus m plus 2. Why we are taking j minus. So j minus 5 m plus 2. Okay, so m is now, m length is 6. 6, so 6 plus 2. Okay, so now it's just 1. Yeah, that means if pattern is matched, we are shifting one position. Okay, so we are deciding the j value for that. Okay, so we are shifting by 1. And if the value are not matched, so this is the first condition. This is clear, I think. Else we are shifting 1. Okay,
Sir,
so
could you paste this particular code similar to previous one? No? Could you paste this one and explain, sir? It is easy.
so I'm explaining this now. So this part actually in this code, we are not using till now any this fail value. Okay, so this part is simple if our pattern is matched. So here you can see that we are starting from the first character in both pattern and text. Now j is pointing to the text and k is pointing to the pattern. Okay, we are starting comparison from here. T of j equal to p of k. If both the characters are matched, then we are checking this. If k equal to m minus 1, that means this condition is representing if we have reached at the last position. Okay, so during comparison, for example, if we are comparing these things, so we will start from the 0 0 position. So k equal to 0, j equal to 0, and at any time we are comparing all character, and at any time we are reaching this last position, and this is also matched. Okay, so in that case we can see that our complete pattern have already checked with the text strings, and all characters are similar, so we can decide that
What
this is
the m is the length of p?
yeah, p.
Okay.
Okay, m is the length of p. Here you can see that m is the length of p and n is the length of t.
Okay.
Okay, so that part is only deciding this. If the pattern is completely traversed and all value are meshed, then we can store the answer in our result list, and we will reset this k equal to 0, and we will shift this
What
pattern
are we
according to this
appending? J minus
j equal to j minus m plus 1. That will also represent the
j
uh,
is
yeah, so that will return the 0 index, the starting index in the text. So that value will return the starting index in the text.
okay.
J minus. Okay, so j is now 5. So in this example, you can see
J
that
is 5,
j is now 5, m is 6
6.
total length. Okay, so 5 minus 6 plus 1.
Right.
It will return 0. So it will return actually starting index of where our matching is
Right.
started.
Right.
Okay. In the another case, in the same iteration, so in this another case, when our so our k is not equal to the last character, then we are shifting one by one both. So this is the next part. Okay, so till now this is the only part when the value is matched. So this part is saying that
So
the
this
value is matched
k is equal to 0. Why are we putting k is equal to 0? Again, we are
because
resetting it.
we are resetting it from the first character. After shifting, we will start comparison from the first character.
Okay. And j we are resetting to j minus m plus
Yes.
2
Yeah. So that will shifting by 1.
by 1. Okay.
Okay. So yeah. So this part is now okay. L if so for example this value is this is not okay. So this is not matched. Now tj does not equal to pk. So now we will move to this part. Okay, at any time this is not matched. So L if k is greater than 0, so we will read the k value from our fail function. Okay, now we will see that where this condition is coming. So for example, just increase after shifting one position. So a b uh, a a b c sorry a b c and a b c. So now I've shifted one position now, and we will just check that what. Okay, we will start from the first position. So B and A is not matched. Okay, so now the 0 index is here 0, 1, 2, 3, 4, 5, and okay, so K is pointing to this one 0, and J is pointing to here. Now first value is not matched, and K is 0. Okay, so in that case, that means second condition is also not true. So we are simply using this. So we are increasing j equal to j plus 1.
Right. Right.
Okay. So we are shifting j equal to j plus 1 and our k is remain on the 0. Okay, we are not changing this. So that means we have shifted one position now. So A, B, C, A, B, C. Now the first thing, same thing, C and C, this is not matched. Once again, we'll shift one character. So A, B, C, A, B, C. Now here you can see that now the first, this J is matched with this K. Okay, so 0, 1, 2, 3, 4, 5. And both value are matched. Now we will increase by 1. Okay, so K is now come here and J will come here. Now B and B is also matched. Okay, so we will once again see. Okay, so A, B, A. Okay. So same thing. So K is here. See, this is matched. This A is also matched. This B is also matched. Now, okay, so similarity is coming at this. So K and J. Okay, so at this position, you can see that here is A and here is C. This is not matched. And now the first value is not matched, and our K value is now 5. Okay, so that means second is so second condition is true. Okay, so this case, so this condition is not true. So how we are just using this fail value? So in that case, fail K minus 1 we will read. So what is our K? So if value is not matched, we are coming here. So K, okay, so we are checking the K minus 1
K4 because K was 5, so it'll be fail
Yes.
4.
Okay, so now K equal to 5, we will check the fail value of K4. So here 0, 1, 2, 3, 4, 5. Oh.
Fail
1,
4 is on top, sir. Fail 4 would be 0, 1, 2, 3, 4. It'll be at 2. Yeah.
0, 1, 2, 3, 4. Oh, sorry, this is at 5. Index. Yeah, so fail 4 is for B. That is the last similarity we are getting at this position. Okay, so this position.
Right.
So we will read the fail value for this, and this is 2. Okay, so in that case, that means we are just resetting our K value, and we are not resetting our J value. We are resetting the K value.
So
So
K will become 2.
k will become 2. That means our k will shifted now this position. K.
Okay.
Okay, so what is the benefits for this? So in that case, if you found this, so where the pattern start? This one. Okay. So here, if this A B A, so this A B C. Okay. A B
So
C.
it's clear, sir. The logic is clear because it is not taking k back to right to the beginning like in the other algos. So we are fixing k at c, which is already matching. ABC
Mhm.
is a pattern which is already matched.
Yeah,
So
so
we'll
same things.
start from k.
Okay, got it. So for yeah, so here you can see that this part is not matched. Okay, so we are checking the fail function for the previous part. So for this, we can see that this for this one. So actually, this in our pattern, this part is similar to this part. Okay, and till now you can see, we can see that the length of the similarity is 2. Okay, if
Right.
this we have already matched in the second part of the pattern, that means this is also matched with this first part of the pattern. Okay, so there is no need to compare again from the starting. We will simply start the comparison from this position. So that part we want to skip actually in the this from this fail function.
It's clear, sir.
Okay, so in the suffix part, if any part of the suffix we have already checked, that means that is also coming in the prefix. So we can skip the prefix comparison again. Okay, so these things we can skip. So in that case, we will shift our k and we will start comparison from this position. Okay, so here we are not shifting. We are just resetting our k to check again. We are just saving our comparison, which we have already matched. Okay, so now we will start comparison from the C and this A. So this is not matched now. Okay, so this is not matched. Now k value equal to this time is 2. Now we will check the what is the uh, uh, 2 minus 1. Okay, so 2 minus 1 is this B. What is the B value? This is the 0. So in that case, we will reset our k to 0. Here. Okay, so that means we will start comparison from here. So AA, then we will start comparison in that way. A, B, C, then C, then A, B, C. So here we are not shifting. Actually, we are just using this similarity things, prefix or suffix. If anytime we found we have already matched the suffix part, which is also a prefix, so uh, we can skip the comparison in the next process because that if suffix is matched, that means prefix is also matched from the text. So this is the logic for that, and this is the code. I think it is clear now. This is little bit tricky.
So the beginning of the code, can you just, because that beginning we didn't do. No, this is
So
okay.
yeah,
Here.
beginning is simply we are calculating this length part. If m
Okay.
equal to 0, we are just simply appending the solution. If
Okay.
m equal to 0, okay, so length of
This
pattern is 0, so that means we are returning match equal to append this.
and this fail, this thing we are maintaining that list of
Yeah, so
the.
here we are calling
Okay.
the that upper
Okay.
function, and that
Clear, sir.
it will return the fail list. Okay, after that we are performing the same part. Okay, so I think code is clear for the KMP. So after that, try and another things are remaining. Okay. So one topic is also pending the same things, so which we are doing in the KMP algorithm. Same things we can perform using finite automata. Okay, that is also discussed in the lecture. Uh, okay, one second. So using finite automata. So we can, uh, you know about this finite automata things? because this is a broad topic, finite automata, and this is a big, this is a separate subject. But do you know about this finite automata?
No, sir.
No, sir, no.
The lecture also, it was not very clear, sir.
Yeah. So because of that, we also don't want to go in the deep. But I'm just explaining that actually this finite automata is also used for the this matching things, state pattern matching things. We can also use, and how we can create a finite automata. So finite automata is a machine. So I'm just explaining that. So in finite automata is basically we use some states input. So here this is f, for example. First is called the input. So for example, if we want to create a finite automata for pattern, so same pattern I'm just creating these things. In the last example, so ABC I'm calculating for this. ABC. How we can create a finite automata, and how we can same perform this pattern matching using finite automata. So we can create a finite automata using this pattern. So we will just take the 6 state. So how many characters are there? So 1, 2, 3, 4, 5, 6. Total 6, and we will take one more state. Okay, 7 states. So we can decide in that way: 0, 1, 2, 3, 4, 5, and 6. Okay, and we can simply connect this using the strings A, B, C, and this A, B, and C. Okay, so now we have 3 type of inputs in our patterns: A, B, and C. So this is called the input, and this is called the states. This is the initial state where we will start, and this is the final state. We can represent it using the double circle. Okay, so at any time, if we always start from the initial state when we want to match our pattern. So for example, if we want to match our pattern like this, so A, B, C, A, B, A. Okay, so if we want to check these things, can this string is accepted by this finite automata or not? So we will simply traverse the character from our strings, and we will start from the initial state. So after completion of this strings, if we are at the final state, then we can say that this string is accepted by this finite automata. Otherwise, if we are not at the final state, so we can say that this string is not accepted by our finite automata. So I'm just taking a smaller example. So for example, A, we have two state like this: 0, 1. Okay, here we are getting this A, and we are getting this B. Okay, and we are also taking this B, and we are getting this A. Okay, so we have two input here, A comma B, and two state we have. This is initial state and this is final state. We are saying that. So can we check that what string can be accepted using this finite automata? If I'm saying that uh, A is accepted using this finite automata or not? Okay, so you can start from the traversing from the initial state 0. Just read A, and based on this input, you can traverse according to the edge. This is called the transition. So transition. So using
So
A,
this is
you
not clear. The graph that you've drawn, that 0 to 1, what is this arrows coming within that
so
circular arrow?
arrow is just pointing to that. After reading this input, we can move to one state to another state.
So it's moving from 0 to 0 only.
Yeah, 0 to 0.
Okay.
Okay, so if we are reading this B input, we will move to 0 to 0. Okay, if we are reading from this state, if we are at this 0 state and we are reading A input, we will move to the 1 state. Okay, so after completion of this strings, if we are at final state, so final state is this. So then we can say that this string is accepted by our finite automata.
This from 1 to 0 B state is like moving from 1 to 0.
Okay, just I'm just explaining for this. So for we will always start the initial state. Okay,
Right.
so we are just reading this first character, first input A.
Mhm.
Okay, so so after reading this A, where you can move to one?
No, in A only, nowhere.
No, just check that. No, what is the age? What is the age value from this zero state? After when you are reading this A value, so where you can move? So just check the age character.
Okay. Yeah. So
Okay.
you move
Yeah, so based on this A input, we you can move from 0 to 1.
one, right?
Okay, so when you are reading this A, you can move to one state. Now you are at one state. Okay, now just read the B. Okay, so now when you are at state 1, so where so for B input, uh, where is your edge is going on?
0.
0,
Hmm.
0. So that means after reading B, you are now moving to this 0 again. Okay, now after reading the last character A, so you are once again after getting this A, you are reaching at 1.
Okay.
Okay, so after completion of this strings, if you are at the final state, what is the last position of your 1? And this is final state. So we can say that this string is accepted by this finite automata. Okay, so for example, if I am taking this A B strings, this is accepted by this finite automata or not? So after reading A, you will reach at the 1. Okay, now B, you will come back to the 0. Then A, then you will once again you move to the 1. Then B, you have to come on the 0. So
Okay.
after completion of this, you are now at 0 state. So that means this string is not accepted by
Not
this.
accepted. Right. Okay.
Okay, so this is called the finite automata, and we use this for string matching things in the using this finite automata. What string can be accepted by this finite automata, what cannot be accepted? So same things we are creating here. That means we are creating this finite automata for our pattern. Okay, so how we are creating simply we are just adding all these sequence. That means once we have to find out this all sequence till C, then we will reach at the final state. We are starting from the 0. After reading A, we are moving to the 1 state, then B to the 2 state, and 3 for the next state. Same things. When we are getting the last C, we are reaching at the final state. So in our text, so for example, we will compare this pattern into the text. So we can use this finite automata for our comparison. Okay, but before comparison, we have to create complete finite automata. Okay, so this is only for these pattern characters. But what is the remaining character? So for example, for from 0, now we have the one transition for A, but what is the value for B and C? So we have to find out these things based on this prefix and suffix similarity. Okay, so we can create so we will create the complete finite automation diagram. Then we can see that how we can perform this pattern matching things using this finite automata. So how we can create this? So for ABC, so we can simply create like in that way. So we'll create a table. So here we are just taking this state 0 1 2 3 4 5 6. Here we are taking input A B C, and we are writing here on the our pattern A B C A B C till now here. Okay, so now we can decide that's from, so in our ABC. Okay, so from 0 to A, then we are moving to the uh, one state 1 1 1 to B, then we are moving to the 2, and 2 to C we are moving to the 3, and 3 to A we are moving to the 4, and 4 to B, we are moving to the 5, and 5 to C, we are moving to the 6. Yes. So this I have filled this value based on this connection. Okay, so 0 to A. Okay, when we are reading the A value from 0, we are moving to the 1. So here you can get this thing. So 0 to A, from 0 state, if we are getting this A value as input, we are moving to the 1 state. Okay, so same things from 1, when we are reading the B value, we are moving to the second 2 state. That things I filled. So what will be the remaining? What will be the value for the remaining? So for the first case, so same things we can find out these things. So now for the B and C, now we have only string A. Okay, so there is no suffix and there is no prefix for this single character. So we will simply fill 0. Okay, now for the second, if we are taking this AB, okay, now for AB there is no similarity, there is no there is no length we have found for the prefix as the suffix. Okay, so we will also fill again 0 here. No. Well, just on these things. Okay, no, not in that way. So for A, okay, so when we are filling, so for the single character there is no choice to fill, but when we are coming at this position, okay, so till now we have only one character A in our pattern, and if we are taking A input, okay, so that means if we are just adding 1, so what is the similarity? What is the maximum length of prefix and suffix which are equal, which is 1. Okay, so we will fill 1 state here. And for this position, the now the initial string is A, and we are taking C character. Okay, so AC. Now the what is the maximum length of similarity as a prefix and suffix? 0. We'll fill in that way. Similarity, same things for here. Now this position, we are getting AB as the initial part, and we are reading A. Okay, so what is the length of maximum similarity? 1. Okay, now for the next same things, A, B, B. There is no similarity as a prefix and suffix length 0. Now for this part, so till now we have ABC and we are getting B. So is there any suffix which are equal to the prefix? 0. Same for the next part. So A, B, C, C. For this string is also 0. So we will fill the complete table in that way. So now A, B, C, A. A, B, C, A. Now we are getting this A input. So we will add this A. Now what is the maximum length of this prefix and suffix which are same? So A and A, 1. Okay. And same things for here. So C. So A, B, C, A, C. So for this, there's no 0. And for the next part, so A, B, C, A, B. Here the next character is A. Okay, so what is the similarity is only this one. A, B, A, B. Okay, so this is 1. If I'm adding the B, A, B, C, A, B, now B. So 0. Okay, so now this is completed. Okay, so A, B, C. Okay, now we'll create a complete finite automata using this information, all this value. So okay, so I'll create here now. So 0, 1, 2, 3, 4, 5, 6, and this is final state, this is initial state. Now this is simple A, this is B, and this is C, A, and this is C. Now we will connect all the edge for the remaining. So 0 to A is now 1, 0 to V is 0. Okay, so 0 to B we will create a for B in that way, and 0 to C is also for the same, so B and C. Same for the from the 1. So 1 to A, we are moving to the, okay, so 1 to 1. That in that case in that way. So this is for A, and 1 to C is 0. So 1 to C is 0. C. And similarly, we will create for another 2 to 2 to A. So 2 to.
So this one I didn't understand, sir. That one to C, one to B. This.
So here we are just creating this edge in the finite automata, and this value we have calculated using this information, the suffix and prefix length, which are equal. Okay.
Yeah, this table I understood, sir. So
Hmm.
first one on 0 node we have wrote.
Yeah. So for 0, you can see that when we are reading B, we are moving to the 0 state. So because
Yeah.
of that, I am just moving this
Okay. 0 to 0 is 0 to B is 0.
0. 0 to C is 0. So because of that, I have taken this B oblique C is same state. Okay. So from 1 to A, 1 to A, same state. Okay, 1 to 1. Now 1 to B we have already connected, and 1 to C 0. Okay, so 1 to C, if we are reading, then we will move to the 0 state. Same for the 2. So 2 to A, we are going to the 1 state. Okay, so 2 to A, we are just adding in that way. So 2 to A, and 2 to B, we are moving to the 0, 0, and 2 to C we have already connected. And now same things for the 4. 3 to A, 3 to A is 4, 3 to B and C both are 0. So 3 to, I'm just connecting that, 3 to B and C. And same for 4. So 4 to A is 1. So 4 to A is 1 now. 4 to A is 1. And 4 to B is 5. We have already connected. 4 to C is 0. So 4 to C is 0. Okay. And 5 to A is 1. 5 to A is 1. A. And 5 to B is 0. 5 to B is 0. Is 0. Okay, so now this is our complete finite automation, and after that we can use the pattern matching things. So this finite automation is represent for the pattern. Okay, so if I want to check that if any text, okay, so I'm just taking a text here. Okay, here I'm just taking
Sir,
another.
after by this, what will get after making this finite automation? What will
Yeah, so
get?
same things, pattern matching. We can find out that our pattern is exist in our text or not. Okay, so for
Okay.
example, if I'm taking this T text, and like in that way, so A, B, C, A, B, and now the character is A, B, C, A, B, C. Okay, so in that way. And okay, so for the last things I have missed that all the B. So here this is A, B, C, C, and this is for the all A, B, C. C. All the 6 states. So in that case, for example, this is our text. Okay, and this is our pattern ABC ABC. Okay, so our pattern is ABC ABC. So we can check this using this finite automation that our pattern is exist in our T or not. Okay, so simply just traverse this T. Okay, so I'm just checking that. So we are just reading this A. Okay, so we are moving to this one state. Okay, now B, we are moving to the two state according to the this edges, and then C we are moving to this three state. Now A we are moving to the four state. Now B we are moving to this five state. Okay, and we are getting this A again. Okay, so in that case, where we are moving, you can see that using A we are moving here.
In first state.
Yeah. Hmm. So okay, so five. One thing. So A B C A B. Okay, so A B C A B. Anything value is wrong here. So A B C A B. If I'm taking A here, so okay, so this is all the one. Okay. Correct. B C. So C here. Oh, this value is actually incorrect. So A B C A B. For example, for this position. Okay. No. This is not. So this is already filled. Any value is wrong for A, B, C, A. So for this here, if you're taking this A, so okay, A, and this is called the word length match. If I'm taking C, not matched. Something is wrong actually. If I'm taking this string still now.
Yeah, I have one question here, sir. This aren't we this graph you drawn is for this text ABC with the pattern ABC, right?
Yes.
So here we have to make the comparison na? With this pattern ABC uh, is existing in this graph and how is existing, because this is the text ABC.
No, this is a pattern.
This ABC is the pattern. I
Yes.
thought ABC on top is the pattern. No, that
Uh,
is just a unique.
this ABC is a pattern, and we create a finite automation for this pattern, and this we are taking for the text, and we are checking that this pattern is exists in our text or not.
So this ABC which is coming on top is the unique value of your pattern.
ABC is unique value.
Of the pattern
No,
text.
these are the no. These are the input. How many characters we are using in our pattern?
Yeah, the unique value of your pattern. Na?
Yes, unique characters in our
Unique
pattern.
characters. Yeah.
So okay, so for I'm just using this text things. If so, okay, for traverse these things, so A B. So at this stage, so when we are reading this A from the fifth position, fifth state, we are moving back to the one state. Okay, and then that means till now we have messed with AB. So I think that we are getting wrong. Actually, we have to move this to where we are getting this wrong things. The same things actually we which we have seen in the KMP algorithms. No? So same things we have to actually move for it for when we are getting the dissimilarity. So when we have to move on this two, because that part is already checked. Okay, in our pattern that part is already checked here, so no need to move back from this position. So I think there's something is wrong happening in our calculation. So same things which we have done in the KMP algorithm, same things we can do with the finite automation. So if during traversing during reading this text, at any time if you are reaching at the final state, you can return answer the true.
So this is basically like that last list we had. This
Yes,
graph.
last step. So that reverse, actually that reverse things is
This 5
representing
should
the,
actually hit 2 instead of
yes,
1. That's
that
what you're.
it should hit 2. Yeah.
Okay.
So that is actually reverse edge is representing this last value, which we
Okay.
not last value, fail function
Fail,
value.
fail. Okay.
Yes.
Got it.
Okay, so I think some calculation is happening wrong in some way. So that 5, after if we are getting dissimilarity of at this stage 5, so we should
2.
back to
Right.
this 2 state, because before this that part we have already matched in this year. So same things we are doing here. So using this pattern, so at any time, so for a traversing of this text, at any time if we are reaching at the final state. So for example, if we are starting traversing again, so from state this state, so A, okay. So now we are moving to this. Oh, okay, okay. Yeah, we are moving to back. I think so. When we are getting this A, we are moving to this here. Now we are getting this B. Okay, so now okay, we are moving to in that way. So from this position, A B, then we have found this B, then C here, now then A B C. Then we will reach at the final state. That means we can see that this pattern is exist in our text.
Okay. So
Okay,
that means that k
if
minus
this
1
pattern
is
is,
going back again, k minus 1 to till it's reaching 1. Because from 1 it is matching, sir. Because if you say from 1,
mhm,
then this
yes,
it is going to B, then C, then A, B, and then B, then C.
yes.
Then that is
So actually, here we are skipping only one character, but it should be skip 2
2
characters.
character. Okay.
Yeah, that part is something wrong in
Right,
happen in the
right.
calculation.
Got it.
Okay, otherwise, so for example, if any text, so A B C A B A B C A B, like this. So if you will traverse this strings, you will never will reach at the sixth state, because here the ABC pattern is not there. So for example, if you start from the A, then you can move B C, then A B. But after that, when you are reaching this A, you will move to this one state. Okay, now B, C, then you will come here 3. Okay, now A. Okay, so I'm just taking this A example. So you will, if pattern is not exist in text, you will never reach this
Got it.
final state.
I got the logic. So basically, it's going to the last k, and
Hmm.
if it is the pattern exists, then we can reach to the last state.
Hmm.
Otherwise, you don't reach.
Yeah, you cannot reach here.
Right.
So yeah, using these things, we can just tell you the pattern is exist or not.
Right.
Okay. Okay, we cannot return all the index things. Okay, so we have to use the different approach to return the all index match. But here we can simply return the answer, the pattern is
Right.
exist or not. Okay, so same prefix and suffix common things concept we are using in this finite automation. So because of that, this part is also explained in the lecture, one lecture. But no need to go in the deep this for this finite automation things, because this is the separate area of the learning, and this is very deep in the deep. So okay, so some things is remaining. Try data structure, and yeah, I think only try data structure is remaining.
Regular expressions also.
Regular expression is also discussed in very lightly, not much in detail. Okay, so that part I think we'll cover in the next session.
Right.
So on Friday, on the live coding, before live coding, we will start. We will just discuss this.
Right.
Okay. Yeah. So any other query for OPP exam, you can practice for the graded question, practice programming question and live coding question till week 9. You can. Okay, so week 10 is also not important for the OPP.
Okay.
Sir, in practice session 8.3, the 8.3 that answer is not there. After releasing, I saw that that solution is
Uh,
for 8.3.
8.3.
Yeah, in practice sessions uh, we done in replete, sir. In replete, there are three questions.
Okay, so in okay, Replit. You are talking about the Replit.
Yeah,
So Replit is also available. Question, what you are saying? This is team, and this is September 2022. So what is not available? So Beak 8 problems are available. Three problems. Beak 9 is also available. Three problems. What's your question? Can you repeat?
yeah. In week 8, last two questions, that solution is the I didn't
Oh, okay,
able to
okay. So
solve
in
it,
last,
and
okay,
yeah.
mhm. In last session, I think this two question is not discussed, na?
In not in week 9, sir. Week 9 it is not discussed. Whereas in week 8, last problem I didn't got solution, sir, and in released solution in our supplementary contents, na, this
Oh,
solution is not there.
oh, we have released, I think. So one second, let me just open that. Live coding session. Six, seven. Oh, solution is not released. Okay, okay. Then we will release by tomorrow. Okay, so all practice and all live coding session we will release by tomorrow.
Okay. And for POD, it is till 9. We require to refer all programs, right?
Uh, yeah, till week 9 for OPP exam, you can practice till week 9. Solution part we will release. Okay, so live coding we will release till week 9, and also practice assignment we will also release. Due to OPP exam in the last Sunday, these things are disturbed actually. Okay, so any other query? I think we can stop the recording.
Sir, one more thing that I identified that many of the programs now, I'm looking to buy hard that program because some programs it is uh, somewhere it will come in some function or some class. It is like that. So, is it like that, or we require to?
For OPP, so I think OPP, the question will be based on the algorithms. So for example, you have learned a graph in two weeks, 4 and 5. Okay, so if you know the all algorithms of the week 4 and 5, then you can solve the OPP question. Okay, so one question will come from the graph. Okay, so if you know the graph algorithms, you can simply solve. So not we will not give any difficult uh, code in the OPPA to remember. Okay, so like AVL tree, that things are very difficult to remember. Okay, so for rotation things, so we will not give this type
So
of.
basically, we'll have to make these. The questions will be on functions, or we'll have to do class or classes also in object. Can be any.
Yeah, both type of code can be there.
Okay,
Yeah. So if we are asking any class things, so maybe some part is given. You have
given.
to write
Okay,
any methods for any class. So like,
okay. Because you have to write the whole class will take a long time.
no, 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 no. The question will be a similar type of these all these assignments. You have already seen that.
Right.
Okay, so stop recording option. Okay, so fine. I think no other query.
Nothing.
Yeah.
So,
Thank you, sir. Thank you.
thank
Okay.
you, sir.
Thank you. Okay.
Thank you, sir. Thank you very much.
Okay. Thanks.